Hi, everyone. Let's start with the good news. You are now more than 100 followers across Spotify and Apple Podcasts to follow this show. And this means a lot to me. It means a lot to the founders who come and share their story on the show. And I'm excited to see this community growing. Today, we are going to talk about one of my favorite topics, which is the combination between AI and climate tech. We talked to CarbonRe, a startup that recently got 4.2 million pounds in seed funding. They focus on the cement industry and making the cement production process more efficient by applying AI technology to inform what are the best possible conditions across the cement production process to reduce the use for the very CO2 intensive resources that go into cement production in the first place. We're going to talk to Sherif, who is the founder and CEO of the company, one of the co-founders of the company, and go deep into this very important topic when you consider the fact that cement as an industry is probably the industry that contributes the most to CO2 emissions. I hope you enjoy this episode. And if you do, please spread the word. Talk about this show to your colleagues and friends. Leave us a good review. It would mean a lot to us and to the founders who come on the show. Without further ado, I hope you enjoy this episode with Sherif from CarbonRe. Hello and welcome everyone. I'm Nathan Pomart and this is Loose, the Climate Tech Podcast. Every week we interview a founder and explore the stories, ideas, innovations and businesses behind some of the most inspiring climate tech companies that have a tangible positive impact on our planet. This show is designed to help you learn, instigate optimism and inspire further action towards addressing the climate change challenge that we face as a global community. If you are an entrepreneur, business leader, or investor interested in learning more about the climate tech space and how you can play a part in it, this show is for you. So, Sherif, welcome to the show. Today we're going to be talking about one of the industries that is at an industry level the biggest contributor to CO2 emissions worldwide. That is cement and adjacently steel, which you are aiming to make a lot more efficient and a lot less CO2 intensive using software and artificial intelligence. So I'm excited to dive into it. Welcome. Glad to have you on.
Thanks a lot, Nathan. Really good to be here.
As a way to get us started, would be great to have you tell us the story of when and why you got excited with this opportunity that you are pursuing at CarbonRe.
Thanks a lot, Nathan, and really good to be on the show. And so I, it was, I think, so I've always had an interest in the environment and on the climate change aspect of it. But really, it was only in the 2018-19, I was working on the application of AI for climate, but more on monitoring climate signals using satellite data and AI from space. And that's obviously important. We need to understand what's happening in our climate. We need to understand where emissions are coming from to be able to tackle them. But really, at the end of the day, it's sort of my frustration grew from the fact that we know where the problems are. Like we know where the big things that need to be tackled are. They're not secrets. We know exactly where the big emissions are coming from. And I used to be, like, a long time ago, I was a civil engineer, so I sort of have this general level of kind of awareness of the built environment, and I'm very interested in cities, and I kind of understand a bit, how buildings are made and what things like cement, steel, concrete, and their relationship to climate change. And my biggest frustration was that, in the tech world, there was so much skill and talent going on, what really are trivial problems, right, in terms of where there's social challenges that we're facing, and they were not being applied to the things that are really problematic from an economic point of view. And I was seeing that, there was a lot of talk around climate change around, early 2020 before the pandemic and so on. There was all around the slightly lower hanging fruits, the things we can start solving today, and things like the more hard-to-abate sectors like cement and steel were just really, to a great extent, not being talked about enough. And that was kind of the impetus for starting CarbonRe.
Did you also approach it from a business standpoint, basically, sizing the opportunity for building a big business in that space? And if you thought about it, what was your thought process there?
No, absolutely. And, I mean, the thing is, like, a business makes sense when it solves a real problem. And that always has to be the starting point. There are things that come and go in terms of, things we think, okay, maybe there is a problem that someone has here or there. But we know for certain that the climate challenge is a huge problem. Decarbonization, that the transformation of every single industry that's going to go through is a huge problem and a huge opportunity, because that transformation will mean that there are huge economic opportunities coming from that. And you look at things like, you look at industries like cement and steel, these are hundreds of billions of dollars annually. We're talking about potentially trillions in terms of investment that's going to be needed over the coming decades. They are absolutely fundamental industries, so they're not going anywhere. There are things that come and go. Cement and steel are not going anywhere. They're going to be with us for a very, very long time. And these are, and that transition and the sort of the inevitability of the transition because of the pressure on the climate side means that all of these transformations is going to open up a huge range of economic opportunities. So it's almost, the question is, why did, coming from a technology perspective, people not think about them earlier? And I think partly it's their more traditional, kind of older industries, and as fundamental as they are, the tech world has been often, I think, perhaps too focused on the newer and shinier things, which are great, but at the end of the day, all these industries need to transform, and technology is a big part of that. And I think there's a huge, big missing gap when we started. Now things are changing, and there's a lot more attention to them, but it was a very, very obvious opportunity.
So let's get into the details a bit. Tell us about CarbonRe and your main product, Delta Zero. What exactly do you offer to cement manufacturers? I guess those are your primary target customers. What do you offer to them, and what do you help them do?
We are not just an intelligence company at core, and we're very much an AI first company. So everything we do comes from internal R&D that we do, then we turn into products that provide the value for our customers. And it's a difficult line to, it's not a very easy line to walk across, because we are trying to address issues with artificial intelligence that have never been addressed before in that way, and at the same time providing that valuable products in a very short time frame. Now, what we do is we help cement producers today with our first product, Delta Zero Cement, to do two things at the same time, is to reduce costs and reduce emissions, which is, a very good value proposition from any perspective. Obviously, the way we're doing that is the question, and why hasn't it been done before, or why no one has thought about it before. And essentially, the key thing is to understand is that cement production is an extremely complex manufacturing process. We're talking about, on average, thousands of tons being produced every day in a typical plant. These are under very, very high temperature conditions, 1,450 degrees Celsius, that need to be reached. There's loads of things going on on the chemistry level, on the physics of the materials moving within the process. There's a lot of variation in the process, and in terms of the energy efficiency that happens because of the complexity and because of the differences in inputs. And being able to control that variation has been almost impossible to do today up to now at a good, in a good and efficient way, because you cannot really model these processes with normal computation methods on a live basis. But where AI comes in is that it allows us to abstract things to in a way that you can do that on a live basis, on a dynamic and continuous basis, and be able to respond in real time, and then being able to achieve these efficiencies. So with these efficiencies, essentially what you do is that you can produce the same ton of cement to the same quality, but by using the least amount of fuel possible. And so then you're able to achieve up to 8 to 10% fuel reductions. And given that this is 40% of the CO2 emissions in a ton of cement, and somewhere between 30 and 40% of the cost of a ton of cement, you can see where that becomes a very significant value proposition.
So is it fair to say that your solution, you currently, the approach you take is we're not going to change what the primary inputs to making cement, but we're going to try to make sure we use those much more efficiently, And by doing that, we're saying we can achieve 10% saving on what contributes to 40% of the cost, 40% of the emissions. So we can make cement globally effectively 4% more efficient from a cost and CO2 emissions standpoint, which is which is huge, right? It's a massive contribution for one single industry.
Yeah, and obviously the big question is, okay, but how do we get to that? Obviously that's with cement or steel, all these things, you need to get to net zero, and there is obviously a lot of kind of new ideas and solutions and different potentially cementitious materials being trialed. Now we kind of look at this from both a very pragmatic and a very both from a climate and a market point of view. One is that start from the climate point of view, getting to net zero by 2050 is meaningless unless we start really reducing emissions significantly now, just in terms of global heating, right? So the earlier emissions are cut, the better in terms of the overall heating and damage that they create. So starting today is really important. From the economics and the market point of view, now the reality is you take cement there are 4 billion tons, that's 4 trillion kilograms of the stuff being produced every year. Right? I mean, these are like incredibly unimaginable quantities, and they're made across the world. And why is that possible? It's because cement's main component is limestone, which is the most abundant sedimentary rock on the planet. Basically, the stuff is everywhere, so we can produce it in these massive quantities. Now, when you talk about all the alternatives, yes, these will have an impact over time. But there is no scenario in which cement will not continue to be produced in the billions of tons every year for the next 20, 30 years, because there is nothing that can replace the scale. And we often forget about the scale. So if you have something where you can produce, for example, 20 tons a day today, even if you scale that 1,000 times, that's 20,000 tons a day. That is somewhere like 600,000 tons a year. That's only a small percentage of the actual amount of cement that's done today. So that change is not really going to happen to replace the cement that we have today. And we're going to have to find solutions both in terms of new materials, but also in terms of making the ones we have today much, much lower carbon intensive.
Let's nerd out about your solution for a little bit. What can you tell us about the nature of the data inputs that you take in order for your AI to be able to make recommendations that lead to more efficiency? Do you have sensors that you need to have across the production line in order to capture new data that then enables you to provide intelligent recommendations? How does that work?
Really good question, because obviously data is key to any AI solution. So the last thing is that the industry has invested quite a bit in sort of all the industry 4.0 IoT developments of the past few years, and there is actually quite a bit of data. But often, as we find across many other sectors, that there is a lot of data, but it's not utilized well, because one that doesn't necessarily translate to the other, right? And so the key is how do you make, as a cement producer, how do you make best use of the data we have? There's loads of sensors for all sorts of parts of the process. You're talking about, and a very high resolution as well. And so we use that data to essentially create a digital twin of the process, and then use that to do live optimization sort of on the go to support that, to enable that increase in efficiency.
And what are the actions that this impacts? When you say it's live recommendations, what is then change on the production line? Is it let's put more chemicals, less chemicals, or let's change the temperature? What then gets translated into the production process?
Yeah, so it would be things. So, for example, if you think of how a cement production process works, so in this case, it have different fuel splits. There's a fuel split in different parts of the process. There is how much of it you're doing, how much the feed-in rate of the materials, the things like the controlling for temperatures in different parts. And the key there is that if you think about it as a dynamic system where the outputs are affected by the inputs and the conditions of the system itself, and the inputs vary by things like the quality and properties of different batches of materials, the type of fuel that you're using, and the different batches of fuel that you're using, which should have different properties as well. then the conditions within the process, and think of it as, okay, you're actually having thousands of tons being produced. And that means that there is a lot in terms of physics happening within the process itself. So how do you essentially you may have 6, 7, 8 levers that you can use, but actually which combination is the right one at a given point in time, given the inputs and given what you can predict about the what's going to happen under different conditions. And what you have essentially is that you have a very large space of possibilities. And the key and what AI enables is to be able to find that optimum path within that very large space.
Let's switch and turn to the landscape in which you're operating. Kind of, I'd love to talk about the profile of customers that you are, dealing with or approaching. As far as I understand, you have, if you look at the cement manufacturing industry, you have very large multinational corporations like Lafarge and some of these names. But at the same time, you have a very long tail of smaller, more regional players. And so it's still a fairly fragmented industry. And within that spectrum, who do you perceive as being the beachhead customers that are going to be, experimenting with you as you build your solution?
Yeah, no, absolutely. No, it's just a very interesting question, and it's one we've had to think a lot about. We're in a good position of working with a variety of different customers in both geographically and in terms of size. And without being, cannot get into the details of names, but the broadly speaking, you're gonna have groups that are either very large multinational, kind of medium-sized multinationals that have, some of them have different degrees of digital maturity, different degrees of, even organizationally are quite different. Some of the really big ones have, centralized technical teams. Others have more kind of autonomous subsidiaries. Some are done some experimentation with digital AI solutions. Others have done less. So obviously smaller ones probably have less capacity to do that. And the key is it's not so much, I wouldn't necessarily say that the size or regionally is necessarily the best indicators of which are the best kind of early customers and sort of early adopters and so on. As these things are always to do with sort of culture and approaches and sort of ambition. The nice thing is that, we've had, so when we started the company, it was a full-on pandemic and lockdowns and everything. So we had to start, the assumption was that we were not going to see anyone in person. So we developed the whole business and product on the idea that we can do it all remotely, which ended up being a good thing in that, we've our first trials were in Asia, and we've actually had some really a lot of very open to innovation companies in Asia. Surprisingly, in some way, more so than perhaps in Europe. And I think it's the one maybe criticism I would have in Europe sometimes is that there is sometimes a bit of a conservativeness in terms of trying new innovation in a way that you don't necessarily see in other parts of the world.
And when you see those customers with an appetite to test your solutions, to run pilot projects, what is their key motivation? Is it cost efficiency, or is it the desire to improve the CO2 emission profile of the industry? Of course, it could be both, but what do you observe from your interactions with customers?
Yeah, that's a really, really interesting. And, we've seen that change just even in the past 2 years, right? Obviously, cost is always important, but it's, I would say probably that since last year, it's become even more of an issue because of the energy crisis and the huge increase in fuel prices. I think kind of sharpened minds about, okay, like that's a really key area. But increasingly, I think everyone in the industry is talking and thinking about decarbonization. As these things are, there's always going to be a range of how much is being done, how fast, and so on. But it has become a clear, not necessarily the top priority, but one of the top priorities for the industry is like to find ways, a path to decarbonization. There is also the reality is that cement in particular is very hard to decarbonize because no matter, even if you somehow manage to avoid any fuel emissions, you still have about 50% of the emissions of cement today come from the process and CO2 that's released in from burning limestone. So the only solution to that really is CCUS, CCS. So there is, I think the industry has been getting both internally kind of the sense that either you have to be to try and to decarbonize. Obviously, everyone's been, every industry has been getting more pressure from investors, from the public, from sort of policymakers. And so we've seen some very positive movements in that direction, really things that are quite concrete actions starting to happen. And that's great. That's really good for us. And it's generally, I think, good for the industry.
What have been the learnings from those pilot projects that you've been running since you started the company in terms of your ability to deliver results from the customers? What are the key numbers when you look at how much cost could we save, how much emissions could we reduce?
No, absolutely. So we had kind of in the lucky position that sort of our product was built on, was backed up by research done by one of my co-founders at Cambridge University, where he looked and analyzed the opportunity at various cement facilities and looking at fuel use and fuel costs. And so we have a very solid base of research kind of see, okay, like that's where the opportunity is. I think, since, we started the company, what we started seeing in working with different customers is that those kind of efficiency opportunities exist to a great extent, or to a very similar extent across the board. Now, it's always a little bit different, obviously, from one facility to another. But the fact is, there is a lot of efficiency potential due to not because some producers were not doing the best that they could, but because the tools to do that, to reach these levels of efficiency, have not been available up to now. So kind of that 8 to 10% potential is there. And it's very much kind of what the data is telling us is there. Obviously, for each time you go to a different plant, it will depend a little bit on the specific conditions, what's happening in it, and so on. In terms of emissions, you could actually potentially reach up to 20% reductions in emissions. That's in specific conditions where you are, for example, so coal is the traditional fuel in the industry. But if you switch from coal to alternative fuels, then you both in terms of the combustion efficiencies that you can achieve and the fuel switch, you could reach something like 20%. Now, switching to alternative fuels is usually quite a hard thing to do. And the reason for that is that it kind of affects the operations of the plant. It's much more unpredictable fuels in that there are a variety of things, right? So one day it could be shredded tires, another day it could be plastics, another day it could be some biofuels, so all sorts of different things. And they have different calorific values, they burn in different ways, they have different degrees of moisture, so it becomes a much harder thing to manage. The nice thing is that with AI tools that can help you manage that variation quite a bit.
We talked mostly about cement. I understand that you're also serving steel and glass production facilities. Can you tell us a bit about what are the key differences that you observe across those three different end industries?
Yeah, absolutely. Yeah, so we are very much focused on cement today. We're doing some early exploration in steel and glass, but perhaps if I take a step back and why, that kind of we've sort of looked at that that range of sector as sectors we can work on. So essentially, we look at the problem from a physics and chemistry point of view to start with, right? And it's the idea is if you look at it from in all of these scenarios as well as with other materials, what you're doing is that you're taking a base material, you're applying energy to it to get to either an intermediary or final product. Now, today, we know how to do that production at a at a macro level. We know what the chemistries involved are, but we don't have the tools. We don't have the tools to make this kind of production as efficient as possible because we do not have the granular understanding at any given moment of what's going on. So our kind of thesis is that by applying the math, the computation of machine learning and artificial intelligence to the physics and chemistry of the transformation of materials, you are able to much better understand and model what's going to happen for the materials given any conditions for different materials, for different production processes. And once you have these kind of overall models, which is then there's a lot of R&D, and that's why as a company we do a lot of R&D, but we're starting in one specific area. There is a degree of generalization you can apply across all these industries to enable you to improve any process that involves the transformation of materials under energy. And so kind of this is that transferability, that generalization comes from developing these general models that are able to apply to go from one place to another, from one process to another, and from one material to another. That's obviously a longer term view. So this is more of the sort of our medium to long term plan, and very much kind of an R&D based plan. And then sort of the key is to, okay, like how do we turn these insights as quickly as the early insights into valuable products in the short term, whilst continuing to build the basis of R&D in the future for the bigger solutions.
Today, where are you in the stage of development of your company? Are you running live customers already, or are you at the stage of refining your solution with more pilot projects?
Yeah, no, so we're running live in a few plants. Obviously, we are. It's you can imagine it's there's the product is always evolving, and this is very much of the part of the value proposition, right? And that's this is not a static set of solutions. I mean, we are always releasing, updating new models, putting them into production, which are improving on previous ones. There's plenty of features we have planned. There's plenty of sort of things that we still want to model. So we have that base kind of that first core product, and we're building on top of that. This is very much what big industries are not always used to, that model of that's different from like having a static software product. You get maybe like a release every few years or something with some new features. This is something that from one day to the next, from 1 week to the next, can be improving, and new features are being provided all the time.
And when you think about your product vision and kind of the roadmap and where those new features are taking you compared to what it is today, what is the picture that you paint for yourself and for your team of the product that you can have reached in 2 or 3 years or even beyond that?
Yeah, absolutely. Yeah, no, that really good question. So I think 2 to 3 years is if you look at cement, we're starting with one part of the process. We're starting with the fuel, with the pyro processing, and cement making. But there's lots of other opportunities across that value chain, even in just in cement. So first is kind of expanding within that. There is that generalization of things like pyro processing of materials across different industries, in terms of verticals. And then in the longer term, talking about 5-10 years and so on, then this is very much where sort of that early investment in R&D can start paying off, because you have where there's a huge potential. I mean, what we think is the future of materials really is probably that we'll go through a huge transformation. Is that so far most of the AI talent, most of the AI effort and investment has gone towards predominantly the digital sphere, right? So imagery and voice and so on, which has led to whole lot of disruption and change in these industries. Now, what we're starting to see, and what I believe is the future, really the next decade is going to be huge changes, are in the physical sciences. So the application of AI to biology, physics, and chemistry. We're starting to see some of that in biology and things like drug discovery, protein folding, vaccine design. This is going to come into the materials industry, and that's going to lead to a huge transformation in the way we produce, the way automation helps make things faster and more efficient and differently, and also the way even we think of materials, the way we produce and design new materials, the way we, for example, adapt cements to the local conditions, to the local available materials and substitutes, to making different types of concrete depending on the different things, and being able to do these in ways that are much faster and much more predictable than anything we can do today.
We're reaching the end of our discussion, so I'd love to talk about the round that you raised late last year. Tell us a bit about who are the investors that came on board, and what do you intend to do with the capital? What is the next step that you see for your company, and where you're going to deploy resources?
No, absolutely. So we've been extremely lucky. We've had a fantastic group of investors. We had follow-on from our pre-seed most of our pre-seed investors. So we had follow-ons from the UCL Technology Fund and Albin Capital, from Cambridge Enterprise, from the Clean Growth Fund, which is a major clean tech investor in the UK, and it was led by Planet A, so major PMM German climate tech investor. And fantastic alignment in terms of both the across the board from both the climate significance and the market opportunity. So we raised around to be as maybe nothing too surprising, but to obviously grow the team, really kind of deepen our technical team. So we really invested quite heavily in like amazing software engineering, machine learning engineering, computational chemistry expertise. We have an absolutely top-notch team, and also across the board, across kind of sales and operations and marketing. But broadly speaking, is to kind of been using that investment to accelerate our product development, really bring in, really kind of mature the product as much faster than we could have done, and to really go and reach out to many more customers and expand into many more companies. So, key for us is ship that as much of the product as possible and kind of provide that real value to customers as quickly as possible, and also plan for the future, because I think we're just on the start of something here. We always, obviously, as a founder and CEO, we should kind of you never stop fundraising in some way. Sometimes a bit less actively or than others, but it's a continuous process. So it's always an eye on the next step. It's always an eye on the next fundraise and where we're going to go next from here.
Barry, thank you. It's been a very interesting discussion. I think we only scratched the surface of what you can do with AI in those heavy industry manufacturing. It was a great way to raise the awareness and to get into it. I'd love to have you back on the show and to hear about the progress in a year's time. And in the meantime, I wish good luck to you and the CarbonRe team.
No, would love to be here again. And thanks so much, Nathan. Lovely to talk to you. And thank you very much for the podcast and all the information you provide.
Thanks, Sherif. Bye.
Take care.
You can find out more about CarbonRe on their website, carbonre.com. Check out their careers page for job openings, as they recently completed a raise and are looking to grow their team. Finally, if you enjoyed this episode, if you enjoyed the show, spread the word, leave us a review on your favorite platform, talk about this with your colleagues and your friends. It would help us, it would inspire them, and it would massively support the founders who come on this show.